In this video, I'm going to give a few examples that I think work really well, combining ductless heat pumps, and these are both single zone ductless heat pumps with some auxiliary resistance in homes. The first one is actually an apartment building. So this was an old school building in northwestern Massachusetts that was retrofitted into 12 new apartments, and pretty efficient. Did a good job with insulation, new windows throughout, got the envelope pretty tight. Here is one example apartment. These are the design loads. This is a crude plan, and again, not going crazy with the room by room loads. You know, there obviously was a bathroom, but it had no exterior walls, so it didn't really deserve its own load. You know, it doesn't need to include its own load calculation. Closets, none of that is included. Basically, the main living space, living, dining, kitchen, and then 2 bedrooms. And these were actually on the north side of the house, so up is north for what that's worth. So these loads are fairly modest, and the developer of this project was really cost conscious when it came to HVAC. He was like, God, I spent so much improving the envelope. I really want to save money on HVAC. I'd really like to put a single ductless head in every apartment and have it do all of the heating and cooling. I did the load calcs. I did the kind of the quasi design or at least specification for the system. I strongly encouraged him to, yes, put a single ductless heat pump in each apartment, but also in the bedrooms, put some modest resistance heaters on the wall. And this is what he did, and this worked very well. The cost for installing the resistance heaters were very modest. I think they were all like, 500-watt heaters. They were not huge. And this worked great. Here's one of the ductless heads. Here's one of the resistance heaters. This was during construction. I don't have a nice polished pic of the heater, unfortunately. But the developer was very pleased with both the installed cost and the operating cost. I don't have kilowatt hour charts to show you, but the developer was actually thrilled with the overall operating cost of the building. He paid all of the electric bills for the building, so the heat was included for the occupants. But still, this design approach of one ductless head that was sized for the load of the entire apartment and then modest resistance in the bedrooms worked out very well. Now, occupants were told about this. They were given some simple instructions about how to use their systems. They were told your heat pump is sized for the whole apartment. The heat pump is about 3 times more efficient than the resistance heat in the bedrooms. Keep your bedroom doors open if you don't need privacy to allow the heat from the central space into the bedrooms or cooling from the central space into the bedrooms. And use the resistance heat only when necessary. One other question, which I alluded to briefly, what about cooling? These bedrooms do not have any cooling delivered directly. And if I were giving this, developing this video for people in Georgia or Texas, yeah, I might not be advocating this approach so much. But I've seen this approach work well many times in colder climates. The one ductless head was sized certainly for the entire cooling load of the apartment. It dealt with humidity throughout the whole apartment. The advice to keep bedroom doors open when you don't need the privacy allowed cool air into the apartments. And the developer also put in ceiling fans in the bedrooms. And so that absolutely helped cool the occupants and also mix the air. So it worked very well. Not saying it'll work everywhere. If you have a client that absolutely insists, I 100% need cooling delivered to this space, okay, this may not be the right approach for that client, but it worked very well here, and I've seen it work very well in other applications. Here is one other application. This is a community of homes in southern Maine, design temperature 5 degrees Fahrenheit. And I'm familiar with this development because some friends of mine own this blue home, and I have visited them there several times. There's a bit of a backstory, which I'm not entirely clear on, but I think the developer of this community bought the land and wanted to build summer homes. And he found out, no, I can't build summer homes. Turns out he had to build real homes, comply with energy code, with heating systems that'll be heated and cooled year round. So his default heating system was a single ductless heat pump serving each home. These are 2-bedroom homes. A single 1.5-ton heat pump provided all the heating and cooling for these homes. I say all the heating and cooling. There was some resistance. He did put some auxiliary resistance in the bedrooms because I guess the developer determined that might be needed. I'm not sure if there are any load calculations done or if this was a lucky chance that a 1.5-ton heat pump seemed to work pretty well. If you go, these are modular homes, so I think the boxes were quite efficient when they came from the factory. This was built 2010-ish or so. But you go up in the attic and there's some room for improvement on the air sealing and insulation quality. So this is in no way a super efficient new home. I suspect that there's some pretty good leakage here. And yet, this worked tremendously well. I've talked to my friends who own this home. I've talked to several of their neighbors. They love their heat pumps. They think it works fantastically well. Yes, they do use resistance in the winter, but they expect to use some resistance in the winter in remote corners of the home, and they don't mind it. And the operating cost, everyone I've talked to at this community says the operating cost is very low, very affordable. They love not having an oil tank. They love not having a propane tank. They love not having a burner service every year. It worked out really, really well. Because I'm a geek, when I went to visit my friends once, I calculated the design heating load for their home. Again, not a big deal. Probably took half an hour. I came up with a design heating load of 26,000 BTUs an hour. If I look at the maximum capacity of that heat pump at the design temperature of 5 degrees Fahrenheit, the maximum heat capacity is 21,600 BTUs an hour. Considerably less than the design load. And yet this system worked great. This heat pump, which was sized, maybe slightly undersized, well, definitely slightly undersized for the design load, with some auxiliary resistance, worked phenomenally well. Everybody is pleased, everybody is comfortable. So a really good application. So I encourage people to consider, instead of multi-zone systems with lots of heads everywhere, consider fewer ductless heads. Maybe not a single ductless head per home, maybe one per floor, but in any event, fewer heads combined with thoughtful implementation of resistance heat in bedrooms or other spaces that aren't directly conditioned. This can be a great solution to lower the first cost and actually lower operating cost if you're comparing it to an oversized multi-zone system.